In this example, we're going to show you how to use the Hadoop cluster to do parallel-based orthorectification. We have a command line app within the OSSIM framework that allows us to take any input image or sensor model and reproject it to some output. We'll assume that your Hadoop cluster has the OSSIM API or OSSIM environment installed on it as well. So your head node and all your slave nodes need to have the API available to them. We also use, since we can't read the Hadoop file system directly, we use Hadoop Fuse, and we have a mount point /mnt/dfs1, which points to the Hadoop file system. And so we can, in doing this, we allow any of the standard C++, C, or any type of file APIs to open through the standard operating system calls. So in this example, what we'll start off with, first, let's go ahead and define our job. We're going to create a Hadoop job. So let's go ahead and create a entry point. We'll start. And we'll go to the big data. We're using the Kettle environment to submit jobs to the Hadoop cluster. So we'll do Pentaho MapReduce job. Let's go ahead and connect it up. And let's just go ahead and save that part right now. And we'll call this orthoigen _underscore MapReduce. And we'll hit OK. And now let's open up the settings. We'll do a Hadoop job name. We'll call this orthoigen. And what we'll do is, let's go ahead and define the cluster, and then we'll set up the mapper in a second. So on ours, we have Hadoop-head, and it's on port 8020. The job tracker is also on the same node, Hadoop head, and it's on port 8021. We're going to allow 3 mapper tasks. We're going to enable blocking so we can get some logging within the Kettle environment here. And I will have the log refresh every, let's just say, 10 seconds. And hit OK. And save that. We'll put the other parameters in a minute. Let's now define a mapper. In this particular example, all we need is a mapper. We're going to use the Hadoop interface here for Kettle to just read in the file listing, and from that file listing the files are distributed across the cluster, and then we execute an orthoigen. So in this transform we're going to do an orthoigen. So let's go ahead and save it, and we'll call this orthoigen mapper. And what we'll do first is define an entry and exit point for this transform. Let's go to big data, and we're going to have a MapReduce input and a MapReduce output. So in Kettle, whenever it parses out the files.txt, which is on the Hadoop cluster, it'll map each row of that file into a key value pair. Initially the key is going to be some numeric integer, and the value is actually going to be the file name, and then we can take that and do whatever we want within this transformation here for that file. In this case, what we're going to end up doing is executing a process called OSSIM-orthoigen. So what we'll do first is create a JavaScript. Connect that up. And what we're going to end up doing, we know the key is going to be some numeric value. So for simplicity, what we're going to end up doing, I'm just going to hard code the output here. We're going to create a variable called process equals, and we'll do a string OSSIM-orthoigen --geo. We're going to do a geographic projection, and we're going to take in as input the value key, so you can just double click on the value. And what we're going to do as output is go to mount/data1/hadoop-out key plus dot .tiff. So essentially you're just going to use a key. It's going to be some numeric value. We could do something a little more elaborate by creating unique output files, or even making that as a variable that can be passed into this job. But we're just going to keep this simple. We're going to hard code a few aspects of the orthoigen process just to get the point across of how you can do parallel based orthoigens on a Hadoop cluster. So now that we have the variable defined, we got to specify the field that we're going to pass on, process, and its type is a string, and we will hit OK. That looks good. Make sure your process looks good. So go ahead and put a semicolon at the end. Process equals awesome orthoigen -- geographic projection with the input and an output location. This output location is assumed to exist as a mount point on all the nodes in your cluster, which is pointing to our shared RAID on our system, which is not a Hadoop file system. And we'll hit OK. In Kettle, there's a process execute. We'll go ahead and execute the process. Take the main output of that, and we'll say that process field is called process. And let's just get rid of these spaces and call it result output, the error output, and the exit value. And we'll hit OK. I'm going to do another modified JavaScript. Which essentially, I just cut and paste the previous one so I wouldn't have to drag and drop a new one in. What we're going to do is call this new value equals, and I want to call this exit value plus the file name. So essentially what I'm going to do is say, okay, I want to take the result of the execute process, print out the exit value for the file that we just tried to rectify, and then I want to pass that on as the new value pair within the output of the mapper, and hit OK. Whoops, sorry. I hit the field name, which is called new value. Now we can hit OK. We can save it, and let's connect that up into the final map produce. Whoops. Main output. And what we're going to do is output the value field will be called new value. Now over here we have the input fields. Let's go ahead and define them. We have two strings, string, and output. Make sure that they are passed right. So we pass the key on, and we change the value to give us the exit value and the file name. Now for fun, what we're going to inject into these transforms, let's go ahead and do a log so we can see before and after what's going on. So let's go ahead and put a log, and let's cut and paste two of them. So we'll create a log here, hit yes, double click, let's not print a header, and let's just get the fields and print all the fields out, hit OK. Let's drop that one in. After it's been executed, we'll also do another printout. We'll get all the fields and hit OK. Now we have a mapper processing pipeline, which basically takes the input from Kettle, which basically parses out the files.txt, puts them in key value pairs. We create a process using the modified JavaScript, a process string that can be executed. We write that information out to a log. We execute the orthoigen process, and then we modify the output value, and then we output that to a log as well, and then pass it on to the next stage of the game. So now let's go over here to the orthoigen map reduce, and let's fix the rest of it. So I don't have to, I've done this already before in another one. So what I'm going to do is, there you are. I can never remember this full name, so I'm going to cut and paste it so I don't have to keep looking it up. And we'll go here. Get a job set up. Let's go ahead and do the input format. It's going to be a text input format, and the output is going to be a text output format. And our input path. Now this is a Hadoop file system path. So we'll do /images. And if you go over here and we look at our Hadoop, let's say fs-ls/images, you'll see that we have a files.txt. I'm going to use a standard operating system command, so I'm going to go through the fuse mount point and images/files.txt, and you'll see that we have 3 files going through the fuse mount point that are 2 NITF images and 1 which is a Planck sensor model. So my terminals don't time out. Let's go ahead and give it some. See here. Now the next thing we'll do is add the output, which is images-output. Oops, sorry, images-out. We'll go ahead and clean the output for testing. And what we'll do now is define the cluster settings. Okay, we've already done all the cluster settings. We've verified that. We verified the job setup. And let's go ahead and define the mapper. We do not need a reducer or a combiner in this example. All we're doing is just using the Hadoop cluster as like a scheduling cluster, which just schedules out our orthoigen jobs to each of the nodes, and then just runs and then executes the rectification process and outputs to a geotiff. So let's use by reference. We just saved orthoigen mapper. So let's bring up the orthoigen mapper, and we have map reduce input and map reduce output. These names here correspond to these step names here within the transform. So let's verify and make sure those steps are good. Map reduce input, map reduce output. Now, if we typed everything in properly, we should be able to run this job on the cluster. We assume that the OSSIM environment again is installed on the cluster, and the LD library paths are set up such that all the nodes can see the libraries or the OSSIM libraries. So let's go ahead and hit run. Actually, before we hit run, I'm going to go ahead and clean out /var log Hadoop. Clean out the user logs for each of the nodes in the cluster, and I'm going to go to my head node, my slave node. Control-C, Control-V. Okay, and we'll cat those logs in a second so you can actually see which image that each of the nodes are working on. So hit play and launch. You'll see your status come up over here. You can always go to your status window over here and see. You'll see here that it should be updating every 10 seconds, or roughly about every 10 seconds. It'll show you the update within the process. And if we go over here, see if any of the user logs have started yet. So we go cat user logs job attempt and 0. Standard out. Whoops. Ooh, we have a missing semicolon. So let's go ahead and stop this job real quick with the orthoigen mapper. Okay. Right here, we got our plus sign. Okay, hit OK, and let me resubmit the job. Hit run. RM. And let's resubmit the job. Hit launch. As you can see, we have one of the images have been mapped to this node. If we go over here, we can say cat/var log Hadoop to one of the slave nodes, user logs, job, attempt, standard out. And you can see that this one's already finished. It was already mapped, and now our second log has already ran. And we can go out here and start seeing the outputs. LH/mnt dfs data1 Hadoop out is where I have all the files going. You can see right there the files have already started outputting. This file 0 is going to be probably about 600 megabytes by the time it gets finished. And this concludes an example of setting up a parallel orthoigen process on a Hadoop cluster.